Overview. The aircraft is fitted with ice protection systems to prevent the formation of ice. Airframe ice protection is by hot air from each engine for wing leading edges, tailplane leading edge. Other ice protection is by electrical heating for pitot heads, front static vent plates, Q-field pitot head, windscreens A and B, TAT probes. Each A windscreen is provided with a 2-speed wiper and a manually operated screen wash. An ice detector is fitted to warn the crew of ice accretion. Ice detection. An ice detector mounted on the nose provides automatic warning of ice accretion. The ice detector is controlled by the ice detector switch on the ice protection panel. The switch is normally on and is covered to prevent it being selected off accidentally. The ice detector comprises an AC motor driving a serrated rotor next to a fixed knife-edge cutter. In icing conditions, the cutter shaves the ice which forms on the serrated rotor. This action produces a torque reaction in the motor, which illuminates "Ice detected" on the central warning panel. The annunciator will remain lit for 60 seconds, or until the aircraft is out of icing conditions. Wing ice protection. Wing ice protection is provided by two separate systems: outer wing anti-icing and inner wing de-icing. The complete wing leading edge is anti-iced by hot air, normally supplied from the outer engines 1 and 4. Additional ice protection is provided for the inner section of the wing only, which is de-iced by hot air, normally supplied from the inner engines 2 and 3. If an air supply is unserviceable, air can be supplied to either system from an adjacent engine. Exhaust air is ducted overboard through under-wing vents or at the wingtips across the aileron horn. Outer wing anti-icing is used whenever ice forms on the airframe to keep the leading edge clear of ice. Inner wing de-icing is used during holding and approach in icing conditions to remove built-up ice from the inner section of the wing. Each system has a control switch on the ice protection panel, each one controlling a pair of valves. The valves can only be opened in flight, and each has a not in position selected annunciator. Operation of either outer wing anti-icing or inner wing de-icing is confirmed by wing tail anti-ice on. If an approach is made in icing conditions, inner wing de-icing is used to ensure removal of all ice from the inner wing. If it is not, wing not de-iced illuminates when flaps are selected to remind the crew that insufficient ice protection is being used. If the temperature of an engine air supply is low when outer wing anti-ice or inner wing de-ice are in use, air low temp illuminates. Engine air fault also illuminates to identify which engine air supply is affected. Engine air fault will not illuminate if the engine air valve is selected off. Tail ice protection. The leading edge of the tailplane is anti-iced by hot air from the two bleed air ducts at the rear of the spine. Hot air is supplied via two valves, one in each duct. Downstream of the valves, the ducts merge into one, supplying the leading edge of the tailplane. Exhaust air is ducted overboard through a fin cap vent. The system is inhibited when the aircraft is on the ground. A tail anti-ice switch controls both valves, and each has a not in position selected annunciator. Operation of tail anti-icing is confirmed by wing tail anti-ice on. This annunciator confirms the operation of any of the three airframe ice protection systems. Pitot and static heaters. The pitot heads, static plates, TAT probes and airflow sensor vanes are fitted with electrically heated elements to prevent ice formation. There are three pitot heads mounted on the forward fuselage. The captains on the left-hand side, the first officers on the right-hand side. An auxiliary pitot head is fitted on the right-hand side just below the first officers. A Q-pot pitot static head supplies the control field system and is mounted on the underside of the forward fuselage. Static plates are mounted on each side, immediately below the windscreen B panels. Airflow sensor vanes and the TAT probes are mounted on each side of the forward fuselage. Three switches, labelled left pitot heaters, right pitot heaters and right vane, and auxiliary and left vane, control power to the pitot heaters and airflow sensor vane heaters. The Q-pot pitot static head, TAT probes and static plates are heated automatically when the aircraft is in flight. Failure of any pitot heater, airflow sensor vane heater or the Q-pot pitot static heater is indicated on the ice protection panel. There is no failure indication for a static plate or TAT probe heater. Windscreen heating. The A and B windscreen panels are electrically heated to prevent the formation of ice and mist on them, and to improve their resistance to bird strike. Heating for the left and right A and B panels is controlled from the left and right screen heat switches on the overhead panel. When the aircraft is on the ground, the two A panels are heated at 1/3 power. Full power is applied automatically in flight. The two B panels are always heated at full power. When electrical power is reduced to the essential level, the captain's A panel is heated at 1/3 power. The captain's B panel and both of the first officer's panels are not heated. Each screen is fitted with one normal and two overheat temperature sensors. The normal sensor regulates screen temperature. If the normal sensor fails, screen temperature rises. When either overheat sensor operates, power to the windscreen is disconnected and left or right screen high temp illuminates. When the panel cools down, the heating supplies are restored to the windscreen panel and its temperature is regulated at a higher level than normal. The fault warnings remain illuminated until reset by cycling the appropriate screen heat switch. If screen heat is not selected on at any time, screen heat selected off illuminates on the central status panel. Windscreen wipers. Windscreen wipers are fitted to each A panel and have dedicated control switches. The wipers have two operating speeds: fast and slow. Windscreen wash. The external surfaces of the two A windscreen panels can be cleaned using the windscreen wash system. Pressing the left or right screen wash buttons on the overhead panel will direct fluid onto the screens. The fluid is stored in a reservoir in the electrical equipment bay. Rain repellent. A rain repellent system is fitted to the aircraft, but because of the harmful effects of the fluid, the system is normally disabled. External checks. The aircraft must be clear of all snow, ice and frost before takeoff. However, an exception is made where frost to a limited depth in certain areas may be allowed, as detailed in the manufacturer's operating manual. This is an aircraft limitation. The ice detector cover must be removed and the ice detector inspected for general condition. Before commencing the external checks, the ice detector may be switched on in order to observe rotation of the serrated rotor. The condition of the windscreen wipers and screen wash rain repellent heads must be checked. Pre-flight. After AC power has been applied to the buzz bars, the screen heat and pitot and vane heaters must be checked off. This is confirmed by the 5 heater fail captions. The Q-Feel heater fail caption is not lit because power is not supplied to the heater on the ground. Screen heat selected off should be lit on the master warning system. Outer wing anti-ice, inner wing de-ice, tail anti-ice and ice detect should all be checked off. The associated wing and tail ice protection valve indications should all be checked out. Before engine start, the ice detector is selected on. After engine start, all the heater switches are selected on. The screen heat selected off and all the captions on the ice protection panel should now extinguish. In flight. Icing conditions exist when the indicated outside air temperature is 10 degrees Celsius or below, and visible moisture of any kind is present. Visible moisture includes clouds, fog with visibility less than 1.6 kilometers, rain, snow, sleet, ice crystals. This is an aircraft limitation. Ice may not necessarily form on the airframe during flight in icing conditions. If it does, it will be visible on the windscreen wipers and indicated by ice detected. Tail anti-ice and outer wing anti-ice must be selected on whenever the ice detected warning illuminates or ice is visible on the airframe. When ice detected extinguishes, inner wing de-ice should be selected on for 1 minute before all airframe anti-ice and de-ice is selected off. If any of the airframe de-ice or anti-ice switches are selected on with a takeoff setting selected on the thrust rating panel, the N1 set on the primary engine display will flash to indicate an illegal bleed setting. If ice forms on the airframe during takeoff, tail anti-ice and outer wing anti-ice may be selected on after the TRP is selected to a climb rating or maximum continuous thrust, MCT. If the flaps are still extended, wing not de-iced will illuminate until they are retracted. During the descent, airframe anti-icing must be selected on whenever icing conditions are encountered, even when ice has not formed on the airframe. During prolonged holding, either in icing conditions or when ice forms on the airframe, tail anti-ice and outer wing anti-ice must be selected on. Inner wing de-ice must be selected on for 1 minute at 8 to 10 minute intervals. If ice forms on the airframe during holding, flaps must not be selected and 7 knots must be added to all speeds. At 200 knots and before selecting flaps, inner wing de-ice must be switched on to prevent wing not de-iced from illuminating unnecessarily. Between 500 feet and 200 feet on approach, all airframe anti-ice and de-ice must be selected off. APU air is selected on and all engine air selected off. A landing or a go-around must not be performed with airframe anti-ice or de-ice selected on. Whenever airframe anti-ice or de-ice is selected on or off, the associated valve nips indications must be monitored for correct operation. After engine shutdown, all heaters on the ice protection panel and the ice detector may be selected off.